Welcome. Today we're diving into the world of computer memory, focusing specifically on ROM or read-only memory. Whether you're a tech enthusiast or just curious about how computers work, understanding ROM is essential. ROM plays a crucial role in every computer system, storing important instructions that help your device start up and function properly. In this video, we'll explore what ROM is, how it works, and why it's so important. Let's begin our journey by understanding the basics of ROM and how it differs from other types of memory like RAM. ROM stands for read-only memory. As the name suggests, this type of memory is designed to be read from, not written to, during normal computer operations. Unlike RAM, which is volatile and loses its data when the power is off, ROM retains its contents even when the computer is shut down. This makes ROM ideal for storing firmware and essential instructions that a computer needs to boot up and operate. ROM is a non-volatile memory, meaning its data remains intact without power. It's easy to confuse ROM with RAM, but they serve very different purposes. RAM, or random access memory, is used for temporary data storage while your computer is running. It's fast and can be written to and read from frequently. However, RAM loses all its data when the computer is turned off. ROM, on the other hand, is permanent and stores critical instructions that don't change. This distinction is key to understanding how computers manage memory and why both types are necessary. ROM's primary purpose is to store the firmware or software that is permanently programmed into a computer. This includes the BIOS, which is the first code run by a PC when powered on. The BIOS checks hardware components and loads the operating system. Because ROM is non-volatile, it ensures that these instructions are always available, regardless of whether the computer has been powered off. Without ROM, your computer wouldn't know how to start. There isn't just one kind of ROM. Over the years, several types have been developed to suit different needs. The most basic is mask ROM, which is programmed during manufacturing and cannot be changed. Then there's PROM, or programmable ROM, which can be written to once after manufacturing. EEPROM and EEPROM are erasable types, allowing for updates and changes using special processes. Each type has its own advantages and use cases in the tech world. Mask ROM is the oldest and simplest form of ROM. It is programmed during the manufacturing process, and its contents cannot be altered afterward. This makes it extremely reliable for storing permanent instructions, but it lacks flexibility. If a bug is found or an update is needed, the entire chip must be replaced. Mask ROM is still used in some devices where the instructions never need to change. PROM stands for programmable read-only memory. Unlike mask ROM, PROM is manufactured as a blank chip and can be programmed once after production. This is done using a special device called a PROM programmer. Once programmed, the data cannot be changed or erased. PROM offers more flexibility than mask ROM, making it useful for applications where the final code isn't known at manufacturing time. PROM, or erasable programmable read-only memory, takes flexibility a step further. EEPROM chips can be erased and reprogrammed multiple times. Erasing is done by exposing the chip to ultraviolet light. This feature is especially useful during development and testing, as it allows for corrections and updates. However, erasing EEPROM requires special equipment and is not as convenient as modern alternatives. EEPROM stands for electrically erasable programmable read-only memory. Unlike EEPROM, EEPROM can be erased and reprogrammed using electrical signals, making the process much easier and faster. This type of ROM is widely used in modern computers and devices for storing small amounts of data that may need to be updated, such as configuration settings. EEPROM combines the reliability of ROM with the flexibility of rewritable memory. ROM isn't just found in desktop computers. It's present in a wide range of everyday devices, from smartphones and tablets to washing machines and microwaves. In all these devices, ROM stores the essential instructions that allow them to function correctly. For example, your smartphone's ROM contains the operating system and critical boot instructions, ensuring the device starts up reliably every time. Firmware is a special kind of software stored in ROM. It provides low-level control for a device's specific hardware. Unlike regular software, firmware is tightly linked to the hardware and rarely needs updating. Examples include the BIOS in computers, the control software in printers, and the operating system in embedded devices. Firmware stored in ROM ensures devices operate reliably and consistently. One of the key advantages of ROM is its security. Because the data in ROM cannot be easily altered, it's protected from accidental deletion or malicious tampering. This makes ROM ideal for storing critical instructions that must not be changed, such as the bootloader or system firmware. Security is a major reason why ROM is still widely used in computers and other electronic devices. When you power on your computer, the first thing that happens is the execution of code stored in ROM. This code, often called the BIOS or firmware, checks the hardware and prepares the system to load the operating system from storage. Without ROM, your computer wouldn't know how to start or what to do next. The boot process is a perfect example of ROM's essential role in computing. Embedded systems are specialized computers found in devices like cars, medical equipment, and home appliances. These systems rely heavily on ROM to store the software that controls their operation. Because embedded devices often need to be reliable and secure, ROM is the perfect choice for storing their essential code. This ensures that the device always works as intended, even after power loss. Microcontrollers are tiny computers used in everything from toys to industrial machines. They often use ROM to store the program that tells them how to operate. Because microcontrollers are designed for specific tasks, the code in ROM rarely changes. This makes ROM a cost-effective and reliable solution for these applications, ensuring consistent performance over the device's lifetime. Gaming consoles also use ROM to store their firmware and sometimes even game data. Classic video game cartridges, for example, contained ROM chips with the entire game programmed onto them. This made games fast to load and resistant to corruption. Even modern consoles rely on ROM for their core system software, ensuring a smooth and reliable gaming experience. Routers, switches, and other networking devices use ROM to store their operating systems and configuration data. This ensures that the devices can always start up and function correctly, even after a power outage. ROM provides the stability and reliability needed for critical network infrastructure, making it a key component in the world of networking. Medical devices like pacemakers, infusion pumps, and diagnostic equipment require absolute reliability. ROM is used in these devices to store the software that controls their operation. Because ROM cannot be easily altered, it helps ensure that the device operates safely and consistently, which is critical in medical settings where lives may depend on it. Modern cars are packed with electronic systems from engine control units to infotainment systems. ROM is used to store the software that manages these functions. Because automotive systems must be reliable and resistant to tampering, ROM is the preferred choice for storing their critical code. This helps ensure your car runs smoothly and safely every time you drive. Smart appliances like refrigerators, washing machines, and ovens use ROM to store the software that controls their features. This allows them to operate reliably and consistently, even after being unplugged or losing power. ROM ensures that these appliances always have the instructions they need to function, making them more dependable for everyday use. Industrial machines and robots often use ROM to store the control software that runs their operations. Because these machines are used in demanding environments, reliability is crucial. ROM provides a stable and secure way to store the instructions needed for precise and consistent performance, helping factories and production lines run smoothly. From smart TVs to digital cameras, consumer electronics rely on ROM to store their operating systems and essential software. This ensures that the devices are always ready to use and can recover quickly from power interruptions. ROM's reliability and permanence make it the go-to choice for a wide range of electronic gadgets. Data integrity is a major benefit of using ROM. Because the data in ROM cannot be easily changed, it's less susceptible to corruption or accidental modification. This is especially important for storing critical system instructions, where even a small error could cause major problems. ROM helps ensure that your devices always have the correct information to operate safely. Many computers use ROM to store recovery tools and instructions. If the main operating system becomes corrupted, the system can use the code in ROM to restore itself to a working state. This feature is especially valuable in mission-critical systems where downtime must be minimized. ROM provides a reliable safety net for system recovery. While traditional ROM cannot be updated, modern types like EEPROM allow for software updates. This is important for fixing bugs or adding new features to devices after they've been sold. However, updates to ROM-based firmware are typically done with caution, as errors can render a device unusable. The ability to update ROM has made devices more flexible and longer-lasting. Some ROM chips include security features to prevent unauthorized access or copying of the data they contain. This is especially important in devices that handle sensitive information, such as payment terminals or secure communication equipment. Security-focused ROM helps protect against hacking and data breaches, keeping your information safe. ROM is a cost-effective solution for storing permanent instructions in devices. Because it can be mass-produced with the same data, manufacturers can keep costs low while ensuring reliability. This makes ROM an attractive choice for everything from simple gadgets to complex industrial systems, balancing performance with affordability. ROM chips are designed to consume very little power, making them ideal for battery-powered devices. Because they don't need to be constantly refreshed like RAM, they help extend battery life in portable electronics. This low power consumption is another reason why ROM is so widely used in modern technology. Devices that use ROM for their core instructions tend to have longer lifespans. Because the data in ROM doesn't degrade over time and isn't affected by frequent read operations, it remains reliable for years. This contributes to the durability and longevity of everything from home appliances to industrial machines. When a device is powered on, ROM provides the initial instructions needed to get it up and running. This process, called initialization, sets up the hardware and prepares the system for normal operation. ROM's role in initialization is critical, as it ensures that devices start consistently and correctly every time. ROM helps ensure compatibility between hardware and software by providing a stable foundation for system operation. Because the code in ROM doesn't change, developers can design software that reliably interacts with the hardware. This stability is especially important in embedded systems and specialized devices. Some devices use programmable ROM types to allow for customization during manufacturing. This lets manufacturers tailor devices for specific markets or customers without redesigning the hardware. Customizable ROM provides flexibility while maintaining the reliability of permanent storage. Many older computers and devices still rely on ROM for their core functions. Because ROM is so durable, these legacy systems can continue to operate for decades. This is why you'll often find ROM chips in vintage computers, arcade machines, and other classic electronics that are still in use today. ROM provides a high level of data protection because its contents cannot be easily modified or erased. This makes it ideal for storing critical system instructions and sensitive information. Devices that require a high degree of reliability and security often use ROM to safeguard their most important data. During the manufacturing process, ROM chips can be programmed with the necessary instructions for a device. This streamlines production and ensures that every device leaves the factory ready to operate. The ability to mass-produce ROM with identical data is a major advantage for manufacturers. ROM is often used during device testing to ensure that the hardware functions as expected. By storing test routines and diagnostic tools in ROM, manufacturers can quickly verify that each device meets quality standards before shipping. This helps catch issues early and improves overall product reliability. Some devices allow for ROM upgrades, especially those using EEPROM or similar technologies. This enables users to benefit from new features or bug fixes without replacing the hardware. However, ROM upgrades are typically performed with care to avoid introducing errors that could affect device operation. Because ROM is difficult to alter, it provides a secure foundation for devices that need to resist tampering. Security features built into ROM can help prevent unauthorized access, making it a key component in secure systems like payment terminals and encrypted communication devices. ROM chips are designed for fast access times, allowing devices to start up quickly and operate efficiently. This performance advantage is especially important in systems where speed and reliability are critical, such as embedded controllers and industrial machines. Because ROM is so reliable, devices that use it require less maintenance over their lifetimes. The permanent nature of ROM means there's less risk of data loss or corruption, reducing the need for repairs and support. This makes ROM an attractive choice for devices that must operate unattended for long periods. In safety-critical systems such as medical devices and automotive controls, ROM is used to store the software that ensures safe operation. Because ROM cannot be easily altered, it helps prevent accidental or malicious changes that could compromise safety. This makes ROM a trusted choice in applications where lives may depend on reliable performance. ROM allows manufacturers to scale production efficiently by programming large numbers of chips with the same data. This scalability is important for producing everything from consumer electronics to industrial equipment, ensuring consistency and reliability across all units. As technology evolves, ROM continues to play a vital role in new devices and systems. Advances in ROM technology such as faster access times and greater flexibility are helping to power the next generation of smart devices, from IoT gadgets to autonomous vehicles. ROM's durability and low power consumption contribute to the environmental sustainability of electronic devices. By reducing the need for frequent replacements and minimizing energy use, ROM helps lower the environmental footprint of modern technology. Wrap up: ROM is a foundational technology in the world of computers and electronics. Its permanence, reliability, and security make it indispensable for storing critical instructions and firmware. From powering up your computer to running everyday appliances, ROM ensures that devices operate smoothly and safely. As technology continues to advance, ROM will remain a key player in making our digital world more reliable and efficient.